getting derivatives in first principles, guys, this was a rough one. The chances that you get this in a paper, I'm not going to say is 0, I'll say 0.01, just to cover myself. But it's too much, and you're going to see now when we go through it that it was really too much. So, the question says find the derivative with first principles, meaning that this is your formula that you've got to use. You do have a shortcut method. When you do the shortcut method, fx would be equal to, first you would make this x to the negative 1 plus x. Then the derivative of that would be negative x to the negative 2 plus 1. Now 10 to 1 they would say x squared. Well, not 10 to 1, they would have said it like that because they're not going to simplify taking negative exponents. So that should be your answer, eventually. First thing I taught you is to go do this fx plus h thing at the top. Didn't matter what you do, this was just terrible. So if I did the fx plus h part, what does it mean? Every x plus h part, every x must be substituted for the x plus h. So we've got this 1 over x plus h, and this is just x plus h. So we've got fractions, and what do we do with fractions? LCD, we can put them each on their own denominator. I'm just going to make my denominator 1. What is the LCD then? X plus h, agreed? Bottom was timed with nothing, so the top stayed 1 as well. Bottom was timed with x plus h, so the top is timed with x plus h. So I've got x plus h squared. Remember that I said to you a lot of times in your questions you're going to have x plus h all squared? Happy on that? So we've got x plus h squared, and then we've got to go and simplify that, and we've got 1 plus x squared plus 2hx plus h squared, which I hope you're going to learn to know very quickly, that you always know that answer. That's the part that was coming here now. The fx part was subtract, let me make it like this, subtract the whole thing so it'll become a minus and a minus. Are you all with me? So minus fx will make both of them minus. But the red part is the fx plus h part, which was 1 plus x squared plus 2hx plus h squared over h, and I was trying to let you see a horrible one, and I think I succeeded in the horrible one. Because now, remember, this is now fractions on fractions, and there's more fractions coming. So let's go and see the sums. If I have to go and simplify the rest of it, now I'm going to have to go say, well, wait a second. Oops, I made a mistake. Luckily I saw it now. This denominator wasn't h, it was x plus h, otherwise I would have fallen off the wagon already. Now the LCD of just that top part there would be the LCD of x plus h and x and 1. Now what's that LCD? X plus h and x, right? For that whole thing there, that whole thing. This is going to be timed by 1 over h to help myself. Instead of having all this on top of each other, I'm going to say instead of dividing by h over 1, I'm going to take the whole thing and time it by 1 over h. Makes sense? When it's fractions, that helps you. Right. So now let's go to the LCD story, and don't forget all the nitty-gritties. You can't have this falling away by the wayside. So we've got this denominator of x plus h and x. So I've timed with x. So time the whole thing with x, and what happens? You got x plus x3 plus 2hx squared plus h squared x. Are you happy on that one? We've timed everything with x. Let's do the middle part. So this x has been timed with a bracket. So that minus 1 must be timed with a bracket. And the other, negative x, must also be timed with what? What did I time with this denominator? 1. To get to the new one. By x and x plus h. Now guys, that was just a lot of writing. I would have made it x squared. Are you agreed with that? So that would have been x squared. Just to make it look a little bit better. x squared times x plus h. All of that still to be multiplied by 1 over h. Right? Horrible. Horrible squared. Still, I'm not being able to cancel out the h because this is my purpose. I would like a h that cancels out with this h to simplify, to get rid of the problem. Is that h a problem if I substitute with a 0? Is it a problem if I substitute this with a 0? The denominator doesn't become 0. That one's fine. This is my problem. So, let's simplify all of it and get x plus x to the 3 plus 2h x squared plus h squared x. This will be minus x and minus h. This will be minus x3 minus hx squared x plus h. I'm not timing out because I want to simplify by substitution. And then still times this 1 over h over here all the time. Now I can cancel out, or I can simplify by addition of like terms. The story that I taught you was, if I have how many terms? Two. Then over here, after lots of simplification, 2 should cancel out with 2. So we've got the x and the minus x cancelling out. We've got the x3 and the minus x3 cancelling out with each other. Are you happy on that? Okay. So then, after that, can I sort out the h? How? How do I do that? By factorizing. So that h and this h is going to cancel out. My problem is solved. This can still be 0 with no problem, but the problem is solved. Still, I must write limit of h tending to be 0. And in the bracket after factorization, I have factorized by taking out a common h, 2x squared plus hx minus 1. Right? Taking out the common h. Now that I've sorted out my problem, can I now, after 1, 2, 3, 4, 5 steps, can I now substitute the h with a 0? Yes. Because it's going to be there and there. And what's going to happen to the sum if I do the substitution? It'll be equal to, no more lim here because I'm doing it. I'm substituting. So this will be 2x squared. This will be 0. And then minus 1. Happy on that? Guys, I have missed something. Yes, I have missed something because I'm knowing that I'm aiming for here. Right? So I'm immediately seeing something's not like a. What I did miss is I didn't add this one. And you should have added them. So let me just put it in like this. You should have added 2hx squared and minus 1hx squared. You see it? And that would have given you plus 1hx squared. So then that would be 1x squared h. Are you with me? I'm not going to change it now. Let's leave it. So if I take it out, take it out, take it out, I have to still take out h here. And what's left? Negative x squared. Happy on that? I'm just correcting my mistake. Because this should have actually just been 1x squared now. Happy on that? So then this would be right, and this would still be negative x squared. At the bottom, if I substitute this h with a 0, what's this going to become? X squared. Shouldn't it look like this if I had seen that I must add the like terms? But it's going to now become what? X squared minus 1 over x squared. Now guys, if you got there, I'm quite sure they would have given you full marks for it, since it was such a terrible sum. But how did they then get to this? Because you should actually break them up to see the separate things that you've differentiated. But I think that would have been fine. If you didn't put them each on their own denominator, the answer is then 1 minus 1 over x squared, which I'm happy about because this was minus 1 over x squared at the front, now it's at the back, plus 1 is now at the front, but goodness me, it was terrible. If I had to give you this, I wouldn't just want to give you 5 marks. I would want to give you like 7, and it's not. It's always just 5 marks. Can you get fractions in the test, in the exams? But then it would be something like just 1 over x. Or just 1 over x squared maybe. But not 2 of them, like this was just terrible. Okay, but good exercise. Okay, first principle still. This time I changed it to gx. They don't really often do this, but just so that you've seen it. So if it's fx, the formula is fx is the limit of fx, but now it should be gx plus h minus gx over h. So it's not a major thing. It's just not human to go and say hx with all the other h's here. That's just ridiculous. Are you with me? But they could change it. fx, gx, no problem. But the principle is you go and you do your gx plus h ahead of time so that you can come and substitute it in there. If you do that, what does it mean? Every x becomes an x plus h. So what is this? Negative 2 times x plus h squared plus another x plus h, because sometimes you tend to think if you've done it once, it's done. Every single x must have an x plus h. Common error, guys, if you didn't do this one. Right, now let's simplify. The one that we come to know as it's always there, x squared plus 2hx plus h squared. That can just be left without the brackets. And when I simplify, I've got minus 2x squared minus 4hx minus 2h squared. And it's a five-term expression that's got to come in here. I do think it is worth it to do it ahead of time and just fill it in here together with all the other stuff. So we've still got the limit when h tends to be 0. Everything over h, which is my problem from the start. I can't substitute. Do that substitution of that purple gh plus x. Okay? And then minus the gx will mean what's going to happen here. You're going to have a plus. And you're going to have a minus. If you want to first write it in there with a negative in the bracket of and put gx in there and do it in the next step, it's fine. But here comes the cancelling out of how many terms? 2 of them with 2 others. So let's see. Minus 2x squared, because now it's just say you got a little bit crazy and you didn't do it right. And this was a plus x because of your calculations being wrong. If this was plus x and plus x, I hope you realize that that wasn't right. It should cancel out legally. Otherwise, you're making it work because you know it should work and you're going to lose marks for it. Okay. My purpose was to get rid of this h. Now, after all of this, I can now get to my purpose by taking out a common h. And what's left? Negative 4x minus 2h plus 1 when you take out that h. And now I can legally get rid of that h that's been bothering me from the start so that I'm left with something that I can substitute the h with a 0 in without complications. If I substitute the h with a 0, then it'll just be minus 4x plus 1. So this whole answer is minus 4x plus 1. I neglected to do the shortcut way here at the top, but what would be the shortcut way? Negative 4x plus 1, which we did get. Please remember you will not get 1 mark if you write down that answer unless you did it with this. But you do check yourself on doing that. Right, first principles. Right. If you are going into cubic graphs, you're going to need the technique I'm going to teach you now. The technique I'm teaching you is so that you can factorize, because I'm going to give you cubic expressions, obviously now, because we're going to go cubic graphs. And in the cubic graphs, you're going to be working x-intercepts. So if you're looking for x-intercepts, you always put your y equal to 0. And then what? Then you've got to factorize this. Now you do not know at this very moment how to factorize this. There's a technique that I've got to show you. Now the technique basically comes down to the remainder and factor theorem, which is not technically your syllabus anymore. It was years ago. But the way I'm going to teach it to you is the synthetic division technique that you're going to be working with, which I call Batman, because you've heard something like this when you were doing your quadratic trinomial, right? And you were taught, well, we go for 1 that's 1 times 1 and 1 that's 1 times 1 and cross multiply, and then we want to get the middle one. Everybody knows what I'm talking about? No, fantastic. The first time you were shown this in grade 10, you also didn't know what was going on. So the same thing's going to happen with this one. That's the one that I call James Bond, because it's something that if you don't know what's going on here, it's like a foreign language, it's like spy language, and nobody knows what's going on except us spies. Are you with me? The same thing's going to happen here, and because I like Batman, I called it Batman. So nobody calls it Batman except me. Are you with me? Don't go looking for Batman in a book. This synthetic calculation of division is actually to go and get factors. Now first of all, tell me factors. What type of factors are there? Factorization. Common
Difference
factor?
of squares.
Difference of squares? Trinomial, which I love.
And groupings.
Grouping? Cubic, yes. Sum and difference of cubes. Sum and difference of cubes. So there can be something like x to the third plus 1, which is a cubic graph. But how would you do that? By factorization. With your cubic technique, your 2-term, 3-term answer, right? So there are 5 ones that you've already been taught. Now comes type number 6. It's factorization number 6, if you really want to write something there for yourself. So it's the 6th type of factorization. How to get a factor. Now first of all, if you have a factor means I divide it into something and what's left? Nothing. That's a factor. If you divide something into something else and there's no remainder, you have a factor. And this very technical, very theoretical technique that you're not being taught now is to get through looking for a remainder of 0, you're getting back to the factor. So now guys, there is lots of depth in this, but to show you, just bear with me. First of all, we are going to do long division, but on a short division way, which we call synthetic division. The technique, which you don't know what you're doing, so focus, is you take the coefficients of your expression, of your expression. What are coefficients? What's the coefficient? 1. Negative 1. And negative 3, right? All the coefficients. So the coefficient in this case is 1, negative 1, negative 5, negative 3. I'm trying to do a little James Bond thingy here. Bear with me. So, and then we put it like that, which should remind you a little bit of long division, but backwards. Okay? New technique, focus. So what you're doing then is the following. And you need to write down little notes for yourself. To do the long division, you are now first of all going to take your calculator and find a factor, one factor. Technically, if you are without a calculator sitting somewhere on an island, you are working towards getting something that you can substitute into x to get an answer of 0. If you substitute in and get an answer of 0, you have just found a factor, because that means that the remainder is 0. It doesn't make a lot of sense to you now, but that's actually how you're doing it. You go and search. If I put in a 1 there, it doesn't give me 0. I know because I checked. But if you put a -1 in there, -1 to the power 3 gives you negative 1. -1 squared, or let's do it like this. If you do that, what's your answer going to be? Negative 1. This is negative 1. Because the square of a negative is a positive times a negative is negative. Plus 5, you're not going to do what I'm teaching you here at the moment. You're just going to do it on the calculator. What is this answer? 0. If this happens, you have just found a
Factor.
Now what is the factor? That negative 1 that I put in there is one of my answers. Remember what you said? If x is negative 1, then what should the bracket have been? If you are factorizing and you've got the answer, then you should have worked backwards. But now either you can go search for it this way, which I do not recommend, or you go to your calculator and you go and find within your table method, within your function method, where you go to your equations, you're going to go and find an answer of 0. Now whether you've got the brand new calculator or the older calculator you're going to have to go for the table method, and you have to put in the function with 1x to the power 3 minus 1x squared, everything. If you've got the newer calculator, you're going to put in under equations. You've always had those quadratic ones, not anymore. Now you're going to go to the cubic one. In the cubic one, it asks you for A and B and C and D, because we're going to go for a cubic graph ax3, bx squared, cx plus d from now on. The window in your calculator only shows you A, B, C, and if you go on it, you'll see out of the window it goes to D. If you substitute that in, you will get the answers from your calculator that says x is equal to negative 1 or x is equal to 3. That's just with the calculator not knowing what you're doing. But it's right. I've just told you that it is one of the answers is negative 1. So either you're going to go to calculator and do the newer calculator. It's going to actually give you the answers because it's factorizing it for you. Or you're going to go to your function mode and put in with A, B, and C, D. Well, you're going to put the whole thing in with your x alpha, right? You're going to say 1 x to the power 3 with your alpha x, etc., etc. And then you're going to ask it to go and work out what with x values being substituted from. Now, from where to where? Because it's going to ask you for a step. And it's going to ask you where you want to start and where you want to end. So if you want to start and end, now this is old calculator you need this for. If you want to start and end the functions, you're going to say, let's start at negative 3 and end at positive 3. Originally, if you had to do it with your own brain, searching and searching for one that gives you 0, the arrangement was that the examiners never ask you one that you'll have a 6 or an 8 working. It'll always be one that has either 1, minus 1, 2, minus 2. So then unfortunately, if you didn't have a calculator, you had to go check which one works. 1 doesn't work. Well, minus 1 does. So you have the first factor. Once you have that factor, now you can go back and know that that's one of your brackets. Okay, but if you go to the calculator, you've got to let it search as well, from where to where. And again, the arrangement can't be too wide from 0. So you'll let the steps be 1, and you'll let your starting point and your ending point be negative 3 up to positive 3, and you're searching for an answer of 0. That will give you the factor. That will give you the factor. Once you have the factor, long story, this is what I need to put here. This is what's going to be your first factor. So if your factor, the answer was negative 1, then this should be negative 1 over here. Now this is coming into our Batman technique. So this should be negative 1. Then the method is as follows, which I would just like you to go and try for today. Okay, don't let your brain explode. Long story to get to the negative 1. There were 2 of them if you used the new calculator because it gave you 2. And you could use any which one of them. So I'm choosing negative 1. Then the technique works as follows. You take this 1, and it doesn't have to be 1, it's whatever's here. Take this 1 and you place it down here. So that is just drawn back down there. Whatever it is, if it was a 2, it was a 2, whatever. Technique is the following. Now you say, negative 1 times with 1 is what? Negative 1. And you put it here, negative 1. So I'm saying, you must time it, and then you put your answer there. Then you must add and put your answer there. So guys, this is like freaky Batman stuff, which you do not know until I teach you. So you take this, times the one that's standing there, you multiply, put the answer there, and then you add. This is the technique. Multiply, put the answer there. Then you add -1 and -1, and it gives you -2. Then you repeat. -1 times -1 is +2, which you put there again. I'm not going to scratch the whole thing for you. And then you do what? Add, and you get -3. Then you take -1 times -3 again, and you get +3. And then you add again. Now what's the answer? 0. Now you'll be seeing me doing this all the time, because I know that is the 0, because that will be the remainder, which means I have a factor. Okay, we'll carry on with that tomorrow.
Okay, Mike.